arrived for this last section of Chapter 13. We're now looking at real-life application models to sine and cosine functions. A lot of this can be done in your calculator, so if you want to follow along in your calculator, have it handy. I'm going to show you some cool features on there that we can take advantage of with these guys. So one thing we can do in this first example, they're talking about they gathered a list of data over the course of let's say a 16-hour period. These were the results that they got for tides. I don't know if you've ever looked at a tide chart for the ocean tides coming in and out. It looks like a sine graph. It's actually pretty interesting. But anyway, this was the data that was gathered. So we can actually fit a sine curve through those points in your calculator. So if you want to have your calculator handy, first thing that we're going to do is we're going to go to Stat. We're going to go to Edit. And we're going to create list 1 with our x's, list 2 with your y values. So if you want to take a minute to do that, you can pause and do that. So here's how that's going to look for you. So let me pull this up. So I already went in and did that on my calculator. So I went to Stat, Edit, and I put in all that data for list 1 and list 2 the way you see it here. And then if you go back into Stat, under Calc, remember we did this option before for fitting a linear function through the data points, but we can also fit a sine curve through the function points. And so that's this one right here that says sine reg. So just hit enter on that. You can just leave that as a 3, list 1, list 2. That's all you need to put in there. And it's going to give us, all the information that we would need to put into our sine graph. So here's our A value where we get the amplitude. So they're going to tell you, okay, let's put A as 3.26. They give you the B value right here, the C value, and the D value. So if you just sub those in to 3 sig figs, you got your sine graph. And so that's a cool way of doing those if you wanted to. And that's how you got the function that you see right here within that rectangle. If you wanted to use that equation to sketch a graph, again, this can obviously be done on your calculator. A couple things that you would want to look at for this: if I'm going to sketch my own graph, consider what my domain would be from left to right. If you look at the data points up at the very top, your x is your domain and it goes from 0 to 16. So I'm only graphing this from 0 to 16. So one thing you could do is, if you're going to do this in your calculator, is go to y equals and type this equation in, and then go to the window of your graph and now set these parameters for your window. So I would do my x min as 0 and my x max is 16. And as far as the y values go, well, remember, this is the center of your graph, 13.3. That's the midline of the graph. That was our vertical shift. So I'm centered at 13.3, and I'm going to go this many units above 13.3 and this many units below 13.3. And so, I would set maybe the y minimum to about 8 just to be safe, and the y maximum to 19 or 20 or something like that just to be safe. And then if you hit graph, you'll see all this within your calculator, and so we can use that to help us sketch a graph. Just a reminder, especially for those taking the IB exam, anytime you do a graph on a test, you have to label your y-axis values, at least a few of them, and you have to label x-axis values as well, or that you get marked down for those things. Here's another one that we can do a little bit by hand and a little bit in the calculator. So this one right here, so they're talking about depth of water, t hours after midnight. So the y coordinate is representing depth and t is representing hours, and we're doing this within a 0 to 24 hour period that you're seeing right here. And so a couple questions that they're going to ask you. One is just figuring out the values of p and q. We can do that just looking at the graph that was given to us. So look at our q value here for just a minute. So you can see q is sitting in the place of our amplitude value. And so our amplitude is simply the distance from this midline to here, or it's the distance from the midline to here. And so we just have to figure out what that distance is. The midline is in the middle of those 2 points, and so we can just take the average we can just take the average of our y coordinates to figure out where that midline is that we're getting right there. So if I did 22.7 minus 10.3 and divide that by 2, then I can figure out the average distance between them, and that's going to be our Q value. Remember that in this case our amplitude is stated as a positive. Well, our Q is stated as a positive simply because we started above the midline right here. So if you're starting above the midline, we would state it as a positive. If we would have started below the midline right here, we would state it as a negative. The p-value is wherever this red line is. It's the midline or the center of the graph. This was our vertical shift. We just figured out in question 1 that this distance right here from the midline to the max is 6.2. And so if we just subtract 6.2 from our max, that's going to tell us exactly where this red line is. Or we could have added 6.2 to our minimum, and that would have also given us the value of the midline of the graph. In the first 24-hour period when the depth is 15, so that just means I'm setting the whole thing equal to 15 to get this value. This is solvable by hand. We've done this in this chapter to solve this. If the test says something about showing how to get the answer or showing you the work, or if it gives you the answer and says show how to get this, then you have to do it by hand. But if it doesn't say that, if it just gave the same directions that this question gave, you could also do it in your calculator. So I'll show you how to do that right now as well. So if you go to your calculator and go to y equals and type in this function, make sure your calculator is in radian mode because of this. So once you type that in, then we're going to go to the window, and I'm going to show you this on the calculator. But in the window, I'm going to set my x minimum to 0, my x max to 24. And then as far as my y minimum and maximum, y minimum has to be somewhere at least below 10.3, and your y max above 22.7. So you could go from 10 to 23. You could go a little outside of that and go 5 to 25, whatever. But anyway, if you go to the graph, so I typed in the function. These are the window settings that I'm going to use. And now if I go hit graph, this is the curve that we get for that 24-hour period. Now they said solve for the first time where the depth was 15. So if I go to y equals, my depth was a y value. So if I now graph y equals 15, so you can see that very first point of intersection right there was the first time we had a depth at 15. And so if I want to know what the x-coordinate is for that value, then I'm going to go under Calc. I'm going to choose Intersect. And I'm going to put my cursor near the point of intersection that I want. So I'm going to put it as close as I can to that. It doesn't have to be exactly there, but it's going to ask me a few questions. Just hit enter, 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 and 3.47 is our time. In terms of minutes, remember that is, if we're going to turn that into minutes, so I would do 0.47 times 60 to convert that to minutes, if you want to do it that way. And so that's going to give us this time right here. And if we were going to do that for question number 4, so now it says, well, what about the next time where the depth is 15? And so again, you can either do some of this by hand in order to figure out when that would occur, or you could again do this in your calculator. If you went to the same thing we were already looking at, well, the next time that occurs is right here. And so if I go under Calc and choose Intersect, get my cursor over there and hit enter, 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 then 8.53 is the next time that would occur. And again, if I multiplied 0.53 times 60, I can convert that to minutes. Anyway, moving on. So then the intervals were in that 24-hour where the water is more than 15, would just be that interval from this time to this time that we're getting for that one right there. And again, I just wanted to show you where this is coming from by hand in case you needed to do this without a calculator. But if we figured out that this x value is 3.47, and this is why I'm centered on the y-axis right here. So if this is a length of 3.47, well, the next time that this occurred right here, then I would say, well, right here I'm at 12 in the center. If I did 12 minus 3.47, that would land me on this point right here, which is what we got for the next time. Moving on, last part of the notes. All right, last one here is just going to link us back to a concept where we can take a look at a sine or a cosine function as it is a circular function. So if you, again, consider the unit circle, if you lay out the unit circle from left to right, you do get some type of a curve that looks like this. Instead of if we just see it as a circular function, over time, as you travel through time, this is what the results are doing. And so you can get this sine or cosine graph from laying out the circle from left to right. Anyway, if we look at this problem here, so we have a counterclockwise rotation, which is what you would normally do on a unit circle anyway. They give us a diameter of 8, and center of the wheel is 2 meters above water level. And so here's the picture that they're giving us. So from here to here is 2, which means from here to here is 2, because the diameter is 8. So keep that in mind. Diameter is 8, radius is 4. So if we're two above the water level, then this would be 2 more units to get one full radius of 4. Anyway, they ask us to show that A is 4. So right here we're seeing A in place of where the amplitude would go. So if we're going to show that that is 4, then real simple, we're just saying, well, if the diameter is 8, then the amplitude from here to here is a radius. And so I'm just showing basically 8 divided by 2 would give me a radius of 4, which is our amplitude. If the wheel turns at a rate of 1 rotation every 30 seconds, 1 rotation is a reference to 1 period of the graph. So if we're doing that every 30 seconds, that means my period equals 30. And we know that the period of a sine graph is 2 pi over b. So if I set 2 pi over b equal to 30, then I can show where this value would come from for b. For the last part, determine the times for where it's underwater. That just means we have a depth less than 0. So if we were to lay that out from left to right, so here's where y equals 0. And so we're just trying to figure out between what intervals is it negative or below 0. So in this case, if you were to graph that, so if you find the x-intercepts of the graph, you can see that from this intercept to this x-intercept, we are below 0. And so that's what's going to give us the interval that you see right here. As far as finding those numbers, if you were to set this function equal to 0 and solve for t, right, these are the two values that you would get. You can do that on your calculator if you want. Go to y equals, graph this function. And once it's graphed, if you go under calc and choose the first option that says 0, and then they ask you a couple questions, but you're identifying this 0 first, and you're going to get 17.5. And then you can do it again. You have to go back into calc, choose 0, and do it again for this point right here, and you can get your other x-intercept that way.